We continue our look at navigation problems. This is one of the trickier sorts. Soldiers on a journey travel 3 legs of a hike. They start on a bearing of 150 degrees true for 3 kilometers, then another 5 kilometers on a new bearing of 220 degrees. This is a frequently used type of navigational problem. We need to find the distance back to their starting point, but also the direction, more importantly, that they need to travel to get back to their starting point. So we create a starting point and we draw a compass rose on our starting point, and we have a look at what has happened. They start on a bearing, and I think maybe I would have liked a little bit more space on my compass rose diagram here. I'm just going to start again. Sorry about that. So they start on a bearing of 150 degrees true. Now remember, south is 180, so 150 is heading off down this way when that drawing shows up. And that's 3 kilometers. We know this angle here is 150 degrees. Now don't rush ahead and put the other angle in that we can see there of 30 degrees, because that north-south line won't be where our triangle goes. Now they change direction when they get to here. If you change direction, stop and put in another compass rose, because we'll need this compass rose to draw a reasonable diagram of this next bearing. And the next bearing is 220 degrees true. So, and 5 kilometers. So we'll need to make it a little bit longer and try to get it in about the right position, because this angle around here, sorry, when that turns up, from north to our bearing, to our line that they walked on, is 220 degrees. You can see what we want in our answer. We want to find the distance back to our starting point, but we also want to find the bearing that they have to walk along to get back to their starting point. So if you draw a third compass rose, now you'll see I'm taking a lot of space with this diagram. The reason being, it gets quite complicated. We look for angles that we can put into the diagram. Look for alternate angles. Remember, every single one of those north-south lines is parallel. So our 2 lines of travel, the 3 kilometer line and the 5 kilometer line, are transverse lines between parallel lines, which means we have alternate angles, sometimes corresponding, and generally not co-interior that we use. Alternate angles are our friends. So while we can see that the angle I just marked with a dot is 30 degrees, it's not a full angle in the triangle, but we can see that the other one I marked with a dot, just here on my second compass rose, is also 30 degrees. And that means that I have, let's just pop in a little comment there, 30 degrees. That means that I have all the angles round from my 3 kilometer line to my 5 kilometer line, 220 degrees, and 30 degrees means it's 250, which means, since this is one whole rotation, if I add in this angle here, 360 minus 250 gives me 110 degrees inside that triangle. And now I have two sides and the included angle, and I can thus use the cosine rule to get the side opposite. And that's the first thing I want. Now this is going to end up quite a long video. Feel free to try to work out side x and then check my answer to see if it's right. So our sine rule, sorry, our cosine rule substitute our values in. I won't put you through, sorry, that's 110 up here where I've got my angle. I won't put you through the calculator. So c squared is 44.261, and we're going to be using c later, and we'll probably want quite an accurate number, so we may wish to use it as that square root there, but I've got 6.65, so x is 6.65 kilometers that they've got to walk to get back home. So I can put x equals 6.65, because now of course what I need is their bearing. So I need to find some angles off this third compass rose down here. And that can be a little bit more tricky. So have a look at it. Remember, we're looking for alternate angles, and see if you can spot anything. Give it a think for just a minute, and then we'll work out where those are. So if you've had a think about it, we're looking for alternate angles. There is this angle here. Remember, our alternate angles, oh come on, the delay on this is annoying, sorry. This angle here, right there in our third compass rose. Now it's not very much help to us immediately because it goes over our triangle, but that's the only space that we can, or one of the only spaces we can easily get an alternate angle. It has to touch that north-south line. We could, of course, have this other one as an alternate angle. Either one will work. So what's alternate to our first angle that we marked? It's this angle on our second compass rose from the south line around to our line where they walked of 5 kilometers. And we can work out what that is. All the way around from north to that was their bearing of 220. Take away 180 from north to south, and I'm left with this at 40 degrees. So I realize it's takes a lot of thinking to work out where these angles are, and a lot of practice of doing question after question. that means that this whole angle down here on my compass rose is 40 degrees. But so far, that's no use to me. That's not a bearing of 40. That would get them back to the second compass rose. But of course, what I can do is I can find just the angle in the triangle, which I've marked here, and then take that away from 40 to find, I'm running out of space to mark angles, this angle right up to the bearing line, which I've marked just here. So it's a few steps. It's a very, very good idea to redraw your triangle at this point. We're getting far too complicated. Redraw the triangle. I've got 110 degrees there, and I want, oh, sorry about that. I want the angle that's marked. I have 3 sides and an angle, so I can use the sine rule with this pair of side and angle, and I've got the side opposite the angle I want. So let's call that angle A, side A, and angle B and side B. And for once we get to use the sine rule. We could use the cosine rule, of course, if we wanted, because I've got 3 sides and I want an angle. We might as well get some practice with the sine rule. Sine A over A equals sine B over B. My working's going to get exceedingly messy here. Sine A over 3 is sine of 110 degrees. I'm running out of page again. Over B was 6.65. Alright, sorry we're about to lose my beautiful diagram, but so be it. So that was sine A equals 3 sine of 110 degrees over 6.65. Now we could have used, instead of 6.65, the square root of 44.261 that we had before, which was just a little bit more accurate, because remember we don't want to round too early. But either way, we want angle A, so it's going to be inverse sine of 3 sine 110 degrees on 6.65, and angle A I jumped ahead there to do the calculation because we're taking so long. 25.08, remember we need to get that into DMS. Angle A is 25 degrees 5 minutes. Now we would have ended up a little bit more accurate if we'd used a slightly more accurate version of our side length there, which would have been perhaps a better idea. Now, that's not our bearing. Firstly, that's an angle, and secondly, that's an angle back in our triangle. So we go back to our triangle. That was angle A. In my little triangle just here, that was 25 degrees 5 minutes. That was this little angle right here at the bottom of the triangle in my big diagram. I've got the larger angle of 40 degrees from north all the way over to this last line. So I'm going to do 40 degrees minus our 25 degrees 5 minutes. (14.9 degrees). Remember, of course, we change that back. We've got DMS. And we have a bearing, or we have this angle here, all this drawing of 14 degrees 55 minutes. And because that's east of north, our final bearing is north 14 degrees 55 minutes east for how far? 6.65 kilometers. 16 minutes to explain and to solve that question. These navigation questions get long and tricky. Draw large diagrams, draw them carefully, look for alternate angles. Good luck.